Download this code from codegive.com, link in the description below. Building your own LLM, large language model, classification system involves several steps, from data collection to model deployment. Below is a tutorial that outlines the process in 5 steps, complete with code examples using Python and common libraries such as Hugging Faces, Transformers and PyTorch. Step 1. Data collection and pre-processing. Before you can train a classification model, you'll need a dataset. For this example, let's assume you have a text dataset with labels. Example code. Python. Import pandas as PD. From sklearn.model_selection import train_test_split. Load your dataset. Data equals PD read_CSV, path/to/your/dataset.csv, adjust path. Check the first few rows. Print, data.head. Assume your dataset has text and label columns. Texts equals data text.tolist. Labels equals data label.tolist. Split the dataset into training and test sets. Train_texts, test_texts, train_labels, test_labels equals train_test_split. Texts, labels, test_size equals 0.2, random_state equals 42. Step 2, tokenization. Tokenization is the process of converting text into a format that the model can understand. You can use a tokenizer from Hugging Faces Transformers library. Example code. Python. From Transformers import auto tokenizer. Choose a pre-trained model. Model_name equals Distilbert-Basunkist. Tokenizer equals auto tokenizer. From pre-trained, model_name. Tokenize the texts. Train_encodings equals tokenizer, train_texts, truncation equals true, padding equals true. Test_encodings equals tokenizer, test_texts, truncation equals true, padding equals true. Step 3, create a dataset class. To feed the tokenized data into a model, you can create a PyTorch dataset class. Example code. Python. Import torch. Class text dataset, torch.utils.data.dataset. Def__init__, self, encodings, labels. Self.encodings equals encodings. Self.labels equals labels. Def__getItem__, self, IDX. Item equals key, torch.tensor, val IDX, for key, val in self.encodings.items. Item labels equals torch.tensor, self.labels IDX. Return item. Def__len__, self. Return len, self.labels. Create datasets. Train_dataset equals text dataset, train_encodings, train_labels. Test_dataset equals text dataset, test_encodings, test_labels. Step 4, train the model. Next, you will set up the model for training. You can use the pre-trained model from Hugging Face and fine-tune it on your dataset. Example code. Python. From Transformers import auto model for sequence classification, trainer, training arguments. Load a pre-trained model. Model equals auto model for sequence classification. From_pre-trained, model_name, number_labels equals len, set, labels. Define training arguments. Training_args equals training arguments. Output_dir equals /results. Number underscore train underscore epochs equals 3. Per underscore device underscore train underscore batch underscore size equals 16. Per underscore device underscore eval underscore batch underscore size equals 64. Warm-up underscore steps equals 500. Weight underscore decay equals 0.01. Logging underscore dir equals /logs. Logging underscore steps equals 10. Initialize trainer. Trainer equals trainer. Model equals model. Args equals training underscore args. Train underscore dataset equals train underscore dataset. Eval underscore dataset equals test underscore dataset. Start training. Trainer.train. Step 5, evaluate and deploy the model. After training, evaluate your model's performance and deploy it. Example code for evaluation. Python. Evaluate the model. Trainer.evaluate. Save the model. Model.save underscore pre-trained, /my underscore model. Tokenizer.save underscore pre-trained, /my underscore model. Example code for deployment. You can deploy your model using FastAPI or Flask. Below is a simple FastAPI example. Python. From FastAPI import FastAPI. From Pedantic import base model. From Transformers import auto model for sequence classification, auto tokenizer. Import torch. App equals FastAPI. Load model and tokenizer. Model equals auto model for sequence classification. From underscore pre-trained, /my underscore model. Tokenizer equals auto tokenizer. From underscore pre-trained, /my underscore model. Class text input, base model. Text, str. At app post, /predict. Def predict, input, text input. Inputs equals tokenizer, input.text, return underscore tensors equals pt. With torch.no underscore grad. Logits equals model, inputs, logits. Predicted underscore class equals logits.argmax, item. Return predicted underscore class, predicted underscore class. To run the API, unicorn file name app reload. Conclusion. In this tutorial, we covered the 5 key steps to build your own LLM classification system. You learned how to collect and pre-process data, tokenize it, create a dataset class, train a model, and finally evaluate and deploy it. Adjust the code snippets according to your specific use case, and feel free to experiment with different models and parameters.